So we will see something about an FF14. There are certain, actually this book is very big, and there are certain points given here. So let us see here. So this is basically this, what I think is an FF14 is mostly given towards the electrical side of the fire alarm. Okay, because here the signaling electrical cables, those things will be given, but still there are certain things which are given which is required for us. Let us try to understand those things. Like that, here they have given the first point, the application. Alarm system shall be classified as followed. Here they have given what are the types of alarm system. Okay, so household fire alarm system, protected fire alarm system, supervisory station alarm system. Some classification is given. Also the emergency communication system classification is also given here. One way, two way emergency communication system. Okay, 1 minute. Yeah. And there are certain things they have written. So these 2 points I find a little bit important here. So if you go apart from that, they have given the purpose here. Okay, like what is the purpose of this code is to define the means, okay, of signal initiation, transmission, notification, annunciation. So whatever the purpose here is given, this basically is like the electrical terms actually. Okay, and here they have written certain purpose here about the NFPA, about the fire alarm system, and here certain like standards are given, some units conversion definitions. So those things will come. See here, some definitions are given here. So these definitions are basically related with fire alarm system only. Like if you see some important definitions here. Okay, alarm box, air sampling type detector. So almost all the definitions are given here. And so many different things are given. Even I think they have given definition for the detectors also. Somewhere if you go a little bit down, you will see some definitions about the detectors also they have given. See this here, they have given some definitions about the detectors. Different types of detector: automatic fire detector, fire extinguisher detector, combination detector, heat detector, line type detector, gas detectors, fire gas detector. Okay, so these are the definitions given here about the detectors. Multi-sensor detectors, different detectors are given here. Rate of rise detectors, this is also somewhat okay. Here you can see rate of rise detector, smoke detector, different detectors are given here. And after that, so many definitions are given here. I think you can see these definitions, whatever the definitions are given here. And after this definitions, let us see what is the important section they have given here. After the definitions, if we just skip this part, and they have given something different chapter. Okay, here after directly this 3 chapters they have not given here. Documentation, let us see what they have given here. Design documentation, I think this is certain step procedure for design, something is given like that. So again, this thing is not required for us actually. You can just skip these things. Shop drawings, documentation, riser diagram, typical wiring diagram. These things are given mostly for the electrical requirement. Or leave this, we will leave these things. My purpose is to check any important points related with the detectors here, like any spacing between the detectors or any clauses related to detectors. We are trying to find those things. Otherwise, there are so many unnecessary things given here, and mostly they have given about the fire alarm system, electrical requirement, and some electronics requirement actually. And if you go here, you will see that all the voltage, temperature, again that electrical requirements are given here. Just skip power supply sources, UPS, Power supply, they're talking about the power supply, about the UPS system, secondary power, primary power system. Even these things are not required for us. So just go down. So many things are given here. Testing supervisory documentation. Okay, we will just skip this. Circuit and pathways. Now maybe this chapter they are talking about the circuits, whatever the circuits looping systems are made in fire alarm system. So they are talking about those things here. Just skip this and see here they have given certain like alarm initiating devices. Some procedures are given here. So these things you can see: two-way communication, single-way communication. And after that, what is the next chapter they have given? Okay, pathway. Okay, this is the different. Again, this is also electrical inspection, testing and maintenance of the fire alarm system apparatus. I think so. Here, this, see here. I think this is the one of the table which we use if you want to know the maintenance of the fire alarm system. Like here, it will be given the periodic frequency, what is the method, and what is the reference, initial reactivation. And here you can find each and every component related with the fire alarm system. So this particular table I think is little bit important, just to only know about the equipments. Different types of equipments are given here, and it's a very big topic actually. You will see that there are so many things given here, and so many things are given here. And here they have given the method also, what you have to do. Apart from that, testing, even here also they have given the testing for different equipments. So this table also you can see. And this is also very big, and this entire thing is given for electrical and electronics requirement only. So you can just skip this. So many things are given here, and just skip these things. And then next what they have given, okay, this same chapter is going on inspection, testing and maintenance. And here initiating devices. I think from this chapter they will be talking about different initiating devices. Anything, let us try to find any important thing if we come across. Here they have given, okay, this thing is not required, you can leave this. Requirement for smoke and heat detectors. Now I think from here they have given the initiating devices, like for smoke and heat detectors, what is the detector coverage. Okay, here I think these chapters are little bit important here. What is the recess mounting, what is the partition, total coverage where required by other government unless other modified, total coverage that include all room above and above as well inside. Okay, they have not given any like coverage here, you need to search, and certain points are given, certain clauses are given. And here you see they have given one range 50 square feet, 4.6 square meter, where the ceiling attached directly to the, okay, this some things are given here. Detector shall not be required underneath open loading docks and or platform. Some things are given here, but still we haven't found any coverage area. They have not given specifically any coverage area. And temperature ratings, okay, color coding, what is the operating temperature, these things are given here. Temperature classification and color code for heat sensing fire detector. This point is also a little bit important, it is well taken here. So what is the color coding for detectors, this is also given here. Ambient ceiling temperature and smooth, okay. So these are certain clauses related with the uh, related with some detectors, like how to install in the ceiling and all. So those things you can check here. Heat detector spacing reduction based on ceiling height. Okay, this is the spacing. Here they have written ceiling height and up to and including multiple listed by spacing by. So this particular table we have seen in our previous class also. And below that I have written some like standard ratings also, like sorry, standard height also. and standard distance between. So those things can be followed from here. Internal heat sensor. Okay, some things are given here. Location and spacing. The location and spacing of smoke detector shall be based upon the anticipated. Some points are given here about the location and spacing. You can check this also. Protection during. Okay, certain important points are given here. Spot type smoke detector. Another type of smoke detector they have given. The distance between is given here 9.1 meter. Okay, somewhere you can find this point. 9.1 meter is given. The maximum distance you can consider this between smoke detector. And if you go like this only, you will find so many points. If you go, I'm just trying to highlight some important here. What written for a room of 900 square feet. Okay, these things are clauses. So many clauses given here. Projected beam type smoke detectors, air sampling type smoke detectors. Different types of detectors are given here. HVAC. In spaces served by air conditioning, detector shall not be located where airflow prevents operation of the detector. Some things are given here. Smoke detector for control of smoke. Limitations, purpose. So basically this, whatever the chapters we are seeing, whatever this initiating device chapter we are seeing, is talking about the different type of detectors and some clauses, some limitations, some restrictions. Those things are given here. So you can skip this thing. And here I think they have kept how to like place the detector and all. That is given here, I think so. Something detector location requirement for group doorways and this smoke detector, everything is given. And after that, 1 minute. Spacing consideration for flame detectors, radiant energy, general rules. So many things are given here. You can just skip this. The best, I think, the best is you follow that notes. Okay, what notes I have shared you for the spacing of general. Like in that we have seen three types of detectors. One is heat, one is smoke. I think so. So whatever the space, distance, height, so that is the best. Otherwise, if you get some good information from here, you can check this. But this book requires a lot of what you can say. You require a lot of time to study. So after this notification applies, so the requirement shall apply where required by the enforcing. Okay, this is also another thing. Mechanical protection, physical mounting. Maybe they're talking about the mechanical construction of the devices, initiating devices in this particular chapter. I don't find any important thing here. Room spacing for ceiling mounted, room spacing for wall mounted. Okay, this chapter is not required actually for us. What is given, even I am not understanding this. Emergency control function interfaces. So this particular, I think, chapter is entirely for electronics person, the one who are like signal and all. So those kind of things, it can be given here. So you can skip these chapters because we don't require this chapter. Protected premises fire alarm system. Let us see what is given here. Purpose. The system covered in chapter shall be for the protection of life or property or both by indicating the existence of heat, fire. Okay. Software and firmware, circuit design. Here also they have not given anything. Just some points are given here. Inputs. Okay. Some fire alarm input points. Detection devices. Signal initiating. I think this chapter also again is your electronic related only, because whatever the things we can see here, it is the electronics term actually. Apart from that, emergency communication system. This is also the that electronics chapter only. Only the one important chapter what we have seen is the detectors one, the where they're describing about the detectors. One way emergency communication system. I think this one is related with the PA system. Something related with PA system, loudspeakers and all speakers. Those things are given here. You can skip this also. Mostly this particular book is dealing with only electrical requirements. Volume control, these things are not required actually, because little bit complicated things are given here. Let us skip these things. See, all the frequencies and all are given here. Let us skip these things which is not required for, because for PS system also you try to do that calculation only, what we have seen, and for CCTV also just follow that notes only. That will be very useful. Otherwise here there are so many complicated things are given here. Okay, apart from that, what is given here? Illustration for effect of ceiling height, nothing is given. This entire chapters are dealing with the PS system only. All the PS systems they have given. Okay, after this, let us see what is this chapter, performance of. Okay, these things are also not required for us. So many unnecessary things are given here, which we can skip. Not required, not required. Maybe somewhere you will find about the decibels also, like sound decibels and all. You just need to search it, dig it. You might be finding something about the that thing also, sound decibels. You will get here. Other than that, what is this? Okay, this is also the talk back system or the PA system only. Alarm system performance criteria. This is also okay. Supervising station, alarm station. This might be a little bit interesting. How the system, this is also how the circuits and all, and how these things are connected. All the what you can say, uh, electronic system, that thing might be shown here. So this you can see. Apart from that, I don't think any important things are given here. Form 4C, Form 4A. Okay, this is also, I think these things are inside of the equipment. Like what is the electronic circuits and all, those things is shown here. So these are very complicated things. We don't need to like go in depth of those things. Example of smoke alarm, smoke detector placement between 10 feet away in a half feet from the center. Some placements are shown here. Might be this is little bit helpful. Just they have shown the placements, and here's some step overview of the performance based design analysis situation. Not required. Some calculations, even this is not required. Okay. So many things, unnecessary things. Okay, here something is given, detector spacing versus heat release. Okay, these things are also not required for us. Maybe they have written smoke layer volume module. These are the complication things actually. I don't think these things are required for us. So you can just skip these topics. So majorly this NFPA 72 only dealing with the electrical and electronic signals. And apart from that, some information is given about the detectors. Okay. Actually, whenever you are talking about NFPA 72, you have to also talk about NFPA 70 also. NFPA 70 also, I will share it with you. NFPA 70 we will see here. Actually in electrical, we will have the NFPA 70. This is the NFPA 70, or it is NEC, National Electric Code. This is also a very big book, and it is talking everything about the electrical system, but you can search fire alarm system also here. And you just need to check what they have given about the fire alarm system, because here in this NFPA 72 book, you will find some reference where they will tell that go to NFPA 70 or NEC, National Electric Code, for the electrical requirement. So I will share you this book also. If you are coming across any like wiring diagram and all, or if you come across any electrical requirement. So you can check this one also, or if any of your vendor or any of your consultant is like talking in terms of this one, so you can check that also. So basically fire this one is like more than enough for, I think this book is more than enough for you for this fire alarm, the one which we have seen here. So this one is, I think, is covering everything: types of detectors, spacing between two detectors, what is the maximum distance between, and what is the ceiling height we have to maintain for different types of detectors. Those things are given here. So I think this book will definitely, this notes will definitely help you out. And apart from that, you need to just a little bit dig about the NFPS 72. Otherwise, you can do also one more thing. If you don't want to check NFPS 72, go for this book. I have shared you one master NFPA book. Where is that master NFPA book? I need to check that where I have kept that master book. So in that master NFPA book also, I think they have written something about the fire alarm system. You can check that particular book also. One master NFPA book is given. Okay. After that, something here about the stairwell also. I've just taken two examples here. So basically, stairwell pressurization. Normally, what happens in stairwell pressurization means here we have to protect this. We have to maintain positive pressure actually in the stairwell. Why means because in every fire, in every building, there is a refuge area or there is a exit stairways. So in those exit stairways, we have to maintain the positive pressure. So mostly I found this one example, and this one formula is given actually. So there is one book actually, from that book I have written these formulas. So again, to calculate the stairwell pressurization, you should have a knowledge of HVAC, because here also CFM is, we are calculating CFM only, and based on CFM only we have to select the fans or something. So here one example is given here. Suppose if you are doing the calculation for pressurization, leakage flow through doors or windows crack. If you are calculating through the door or windows, this is the formula given, and you will find that majorly they will take the minimum pressure of 50 pascals. Okay, whenever the minimum pressure is taken, that will be the 50 pascal, and there is a n factor given here. 2 doors n is equals to 2 windows n is equals to 1.6, and typical door size they have taken, whatever the door size, width by height, you will know that. Okay, number of typical floors they will take, leakage area in square meter for typical floor they have taken 0.01, total leakage area 12 into 0.01. I will show you this formulas also. Then they have calculated how to find the air required to flow through cracks. This is the total leakage air through the doors and windows. Here through the cracks, they have used this formula only. Same formula, I think so. So here they have calculated AE. This is the AE. And if you input all this value, you will get this value. This is nothing but cubic meter per second. If you convert it into CFM, it will be converted in CFM or cubic meter per hour. So that values are given. And again, they have also done one calculation. If you want to calculate the air quantity through open door, sometime what happens, the door will be opening and closing. So for that, they have used this formula, equation of continuity, Q is equals to A into V. Area of open doors 2 into 0.8. What is this 0.8 means? You have to go back here, 2 into 0.8. Okay, this is the size of the door. Velocity through open door they have maintained, consider 0.75. Air quantity required, Q is equals to A into V. Simple, just multiply area with velocity, 1.2 cms. Total air required to pressurize staircase, just add these two values. This is B, this is A. 1.05 plus 1.2. This is the value you got, 2.256. So here you are supplying this much of air with positive pressure. Okay, positive pressure means the door will not open from what is the meaning of positive pressure, that you should understand first. Normally how this thing will look like means, suppose this is something, our building, for example this is the building and these are the floors for example, and we are maintaining stairwell pressurization in this area. For example, this is our stair, something like this suppose. Okay, you can also connect like this also, zigzag manner. So I want my this area to be protected, for example. So here what we are doing, simply we are maintaining the positive pressure here and negative pressure here. The meaning of negative and positive pressure is that here everywhere you will see one door will be there. For example, what is the meaning of positive pressure means, in simple definition, if this door is closed, for example, if this door is closed, air cannot travel from this point to this point. Okay, air cannot travel from this point to this point. This is the positive pressure. But air can travel back from this point to this point. Okay, air can travel from this point to this point, but air cannot travel from this point to this point, because I have maintained the positive pressure. Just take the example of ICU, operation theater. What happens in operation theater? If you open the main door, like the operation where the patient is being operated, if you open that door, what happens? Whatever the air entrapped in that room, it will come out. But outside air will not enter into that particular room. That is why it is called as positive area or the positive pressure. Now, normally these positive pressures are maintained in where we have to maintain positive pressures in clean rooms. Clean rooms means, for example, pharmaceutical room, or in operation theaters, OT. And also if you want to protect the refuge areas, refuge area is something where in case of fire we have to, like, one area will be made. So in those areas you can maintain this positive pressure. So this also example of the positive pressure only. Here also what they are talking, it is in the positive pressure what they have maintained, how much air is required. For example, they have calculated the air, then what they will do, they will just put one fan here, and with the help of duct, again the same procedure they will follow. They will install one duct here, and from this duct what they will do, they will just supply that air. So some positive pressure will be maintained here, like 50 Pascal or something. Then they have also calculated the air lower size. Why they are calculating this air lower size means, they require the lowers also, like diffusers. Whenever we are talking about the air, we require the lowers, because how air will pass, with the help of the lowers, the air will be supplied here. So here they have done the air lower calculation. Again, they have used the same formula, equation of continuity, where they have they know two values, Q and V. They have calculated the lower size area. Simple thing. Pressure relief size. If you want sometimes pressure relief valves also, like you want to use some pressure relief valve, this is the formula you have to calculate. From this formula only, whatever the first formula is given, Q is equals to 0.83, just they have rewritten it. So every value is known, AE you will get. Then you can also get the size of the lower, what area you have to follow. And if you want to find the side, this is how you can find. 0.48 square meter is equals to area square, area is equals to side square. And if you just do this thing, you will get the side here. This is one of the example where what you have calculated, the flow of the pressure, sorry, the flow of air, pressure is maintained at 50 Pascal and the lower size. There is one more example given here. In this example, what we can see, suppose they have given some input data, the number of floors, average floor height, exterior building 420 meter, wall tightness. They have taken some value here, wall tightness. 1 is tight, 2 is average, 3 is loose, 4 is very loose. Stairwell wall area per floor. That means how much area is covered for stairwell. Every floor 74 square meter. Wall tightness 2. Gap around each stairwell door. Suppose if you have any gaps between the door to, like wherever your stair is going between the door, so that gap they have maintained here. 0.024 square meter standard they have taken. Outside design temperature is 45 degrees Celsius. Stairwell you want to maintain 24 degrees Celsius, because this is also considered as a human comfort zone only. Stairwell door dimension, width into dimension, whatever the dimensions that they have taken. Now here, first what they have done means force to overcome door closer. Suppose if you are using the force door closer, sometime we have the door closer, door stopper. So that force is taken as 53 Newton. Distance from door knob to edge of the knob side of the door, 75 mm. Whatever the door knob we are having. So if that distance they have taken the standard value 75 mm, then they are taking the assumptions. Pressure distance between stairwell and business at stairwell bottom, 12.4 Pascal. 20 Pascal is the standard value. Critical velocity. The velocity which is like critical velocity is nothing but it's a velocity when anything occurs, I think so, like stairwell, whenever any fire occurs or simply whatever the velocity you want to maintain. Then maximum allowable pressure difference between stairwell and building. Some formula is given here. B, C, D, E. So here I have written also what is C, what is B, what is D, what is E, what is A. Some things are written here. So that thing is given here, and here they have calculated the pressure. How much maximum pressure is required. Height limit below which satisfactory pressurization is possible. So for the high-rise building, maybe they will check the heights also. The heights, whatever the height, this formula is written here. And some H and I, they have written something here. So after that, you will get this value. Height limit below which satisfactory pressurization possible is 107.83 meter. And here what is written, the height, they have not written anything about the height. Here only they have written 32 floors and each floor is 3.2 meter. Here they have written 102.4 meter. And if you are doing the calculation, you are getting some 107. After that, they have written pressure difference per height due to stack effect. So stack effect means whenever you are going up or down, like in plumbing, we have the stack. So here also the stack will happen. That thing is written here. And something value you are getting this one. Flow rate for pressurization, how they have calculated the CFM value means with the help of this formula. But here they have written cubic meter per second or CFM. So this is also one of the method given here. And this book is, I think, this is the very good book I find. Even in internet also you can get. And all the calculation formulas are written from here only. Stairwell pressurization system. Different types of pressurization systems are given here. Like natural ventilated, mechanical ventilated system, stair pressurization system. So here they have written something about the chapter is given here. What are the hazards of smoke? So here the classification is made entirely different. This classification is not, you should not consider this classification with light, ordinary or extra hazard, but this classification is given something related with the toxic or gases, irritant gases. So those things are given here. Limit the fire. Important consideration when designing a smoke control is to ensure that evacuation is faster than the spread of smoke and fire. Certain points are written. Controlling the fire size typically by means of hose pipes, hydrants and sprinklers should be a part of the overall smoke management program. An automatic fire suppression would be expected to limit the heat release rate and control the spread of fire. Compartmentation involves use of barriers with sufficient fire endurance to prevent spread of smoke to space. Some points are written here. Exhaust ventilation. Smoke control in large open areas with high ceilings such as atria, shopping mall can be achieved by exhaust ventilation. So this exhaust ventilation also one of the topic where what you are doing, simply you are exhausting the air, inside air. So I think this particular is very helpful when any fire occurs, so that you can, with the help of exhaust fan, you can extract the smoke from that fans. Hot smoke is collected at the high level in a space where it is vented outside by means of a powered smoking exhausting fan. So maybe what they will do, they will just make one duct kind of thing. So with this duct only, they will be extracting the exhaust air and they will venting out outside of the building. So this is also one of the method is given here. Dilution method clears smoke from space remote from the fire. This method supplies outside air through the HVAC system to dilute smoke. Also, they can use one dilution of smoke also. Using this method helps to maintain acceptable gas and particulate concentration in compartments subject to smoke infiltration from adjacent. In addition, the fire emergency service can employ. Okay. Here they are giving different methods. Okay. Like one is the exhaust ventilation, one is the dilution, the airflow method. One method is the airflow method, controls smokes in spaces that have barriers with one or more large opening. It is used to manage smoke through open doorways, subway, railroads. Some things are given. The disadvantage of the airflow is that it supplies increased oxygen to a fire. Okay, if air is flowing means obviously the oxygen is providing. Then they have given the method pressurization system. This method employs a pressure difference across a barrier to control smoke movement. So normally what happens in pressurization system, the stairwell and the normal well or the normal area, there is a pressure difference maintained because we are maintaining the positive pressure of 50 pascal or 100 pascal, whatever the value. So that is why I think here it has written this method employs a pressure difference across a barrier to control smoke. The pressurization systems are installed mainly in the stairwells, elevator, refuse space or other egress routes. The high pressure side of the barrier is either the refuge area or the exit route. So high pressure means obviously this is the positive pressure. The low pressure is exposed to smoke. So obviously this low pressure is the one which is inside of our exit doors. Okay, that means corridor areas or the lift lobby areas. Okay. Airflow from the high pressure to the low pressure through construction cracks and gaps around the door. Now this point you see cracks and gaps, the same calculation has been done here. Cracks and gaps, whatever the thing is written here, prevent smoke infiltration. A path that channels smoke from the low pressure side to the outside and shows that gas expansion pressure do not become a problem. A top vented elevator shaft or a fan powered exhaust can. So we will focusing on the fan powered exhaust system. One fan will be installed in the terrace. So that will be like sucking all the smokes. Like here they have calculated 12,000 CFM value, 12,200 CFM value. In contrast to exhaust and dilution, the pressures are designed to protect zones away from the fire source. Okay. Important smoke management system designed to modify, dilute, redirect, or otherwise influence the movement of smoke. Some things are given here. Then they will be talking about the smoke control. Smoke control systems are intended to limit or control the movement of smoke during a fire. The most common approach involves using pressure difference on either side. This is also one of the method, I think so. And here they have given the design requirements. Smoke movement. What is the smoke movement? A building can be considered as a series of spaces, each at a specific pressure with air movement between them. Some points are written, but here the important points they have written. There are 4 factors responsible for the pressure differences. Difference in temperature between outdoor and indoor air, which is called as stack effect, natural convection, thermal expansion, wind forces, HVAC operation, buoyancy of conversion gases. Here they have written the entire 6 systems. Stack effect and different. Now they will be talking about each and every system separately. Stack effect is a result of different air densities inside and outside of the building that causes the pressure distribution of air. If the air flow is from bottom to upward, it is normal stack. Okay, this point is also important. It happens in winter when the less dense warmer air rises and cold outside air rushes in to take in place. The reverse happens in summer when the cooler air inside the building sinks and draws warmer air in through the top of the building. Okay, so if the air is flowing from bottom to upward, it is a normal stack effect. So that's why maybe they are keeping the fans in the terrace so that the air smoothly can come from the bottom to the terrace. The stack effect is more pronounced in the winter when it's cold outside. Here they have given something: reverse stack effect, normal stack effect. Okay, and some formulas are given here. How to do the like calculations and all. You can just go through that. This book is very good actually, and so many things they have written. Impact of building height on stack, natural convection. Second point, it results from the temperature difference within a fluid. As a fluid is heated, it expands while mass remains the same. Decreased density makes the heated fluid more buoyant, causing it to rise. So here maybe any liquid, fluid, even air is a fluid if you consider in that term. So maybe here it is talking about that thing. Maybe here it is talking about the buoyancy forces, because Normally in buoyancy forces, what happens? In the surface, the object floats. Like how we swim, we splashes in water. Then after a few minutes, we come back to the surface. So that method here it is showing, I think so. Natural convection is one of the major mechanisms of heat transfer in a compartmental fire, heated air and smoke riser, and cooler air moves in to replace it. This process transfers thermal energy, thereby heating other materials in the compartment, also transfer mass as smoke. Okay, some points are written. Thermal expansion is obviously the expansion. Maybe in the summer it happens. And here they have written the hot gases are expanding. Some formulas are given here. You can just check. Wind forces, wind velocity. Maybe this particular point is happening in the high-rise building where the wind is very huge in the top floors. Wind velocity can have a significant effect on the movement of smoke within a building. The pressure distribution on the surface due to wind is far from uniform. The pressure distribution is okay. Some formulas are given here. And here they have given how the wind effect will happen. Buoyancy of combustible gases, hot gases produced during the fire have a lower density and therefore rises upward due to the thermal buoyancy force. So maybe this is the point. This is the reason why we will see that the fire is spreading very fastly. So maybe that will have a lower density. However, as smoke moves away from the fire, the temperature is lower due to dilution. Therefore, the effect of buoyancy decreases with distance from the fire. HVAC system is also one of the major, what you can say, responsible for fire as per this data. The HVAC system typically supply air at a higher rate than it is extracted. Okay. It is becoming more common for the building to be pressurized. That is at a positive pressure with respect to external. Some points are written. They have summarized it. Okay. And some points are given here. Here they have given the primary means of controlling smoke movement is to developing higher pressure in the areas to be protected in the building adjacent to the compartment of fire origin. This is the primary mean. Now they will talk about the smoke control methods, like which method you have to apply. And here you see they have defined three terms here. High-rise building, smoke refuge area, tenable environment. High-rise building is high-rise building. Refuge area is the building where I told you it is an area where it is constructed by maintaining positive pressure, where there will be some barriers will be given here. Okay, so that smoke or fire cannot reach here. Tenable environment, an environment in which smoke and heat are limited or otherwise restricted to maintain the impact on occupation, not life-threatening. Maybe refuge area and tenable environment both are same only. Now they have given about the active smoke, passive smoke. Active smoke control system uses mechanical equipment to control. It includes pressurization method. So maybe a Stairwell pressurization method is an active smoke method. And passive smoke method is the one where we are using only fire rated walls, barriers, or any smoke vent shafts. So these are the passive method. The international building always allow three active smoke control methods to contain. Here they are talking about the pressurization method. Maybe here they are talking about the pressurization, Stairwell pressurization method. So this particular topic you just see what they have written here, and they have given so many things, calculations and all, and some limitations, the pressure ranges and all is given here. So just check this, what they have given here. So many things are given here. Examples are given here, how to do these calculations. So I think this thing you can easily, and some like how to rescue, those things are also given, negative, positive pressure. They have given system design. Stairwell pressurization system is a mechanical ventilator system. In order to pressurize, it is necessary to install sets of fans that suck air into the stairwell, keeping pressure of 0.1 to 0.45 each water gauge. The main purpose is to prevent infiltration of smoke. Codes and standards followed are, these are the codes and standards they have given. Some codes, pressurization techniques. Okay, this is also some different thing, how this thing is happening, that is also given here. And they have given some images and all. This document is very good actually. And this is, they have shown in the terrace, how the fans are connected. Here you can see the ducts are connected actually. And basically here, they will be maintaining the positive pressure. That is the main thing here. Location of fan, they have given location of fan also, and how it is connected with the duct system, that is shown here. So many things are given. Even they have given something about the fire dampers. If you want to use the fire dampers, pressure relief venting is also given, pressure relief valves, exhaust fan, supply fan, bypass, variable frequency drive, okay, design calculation. Here they have given one design calculation method. One example I think they have given. So you can just check this air leakage method. So this method is given as air leakage method. What we have seen here, this one. I think this one is the air leakage method. So the formula looks entirely similar only. Simplified equation. So many calculation methods are given here. You can go through that. See tight, loose, average. Some values are given here. I think this you can go through that. So many like methods are also given. Example is also given here. Actually, this book, I like this book actually because it has explained in a very beautiful way about the stairwell pressurization. So I hope just follow that. It will be very much easy to understand. So, okay then. Apart from that, I think we have to see one more time like this light software. Okay, like we will see something. We will do some revision actually. We will summarize our topic once, and we will again see this light software. Before that, we will summarize this. And if you have any doubts, like we can discuss tomorrow. Is it okay? And
Okay, sir. At what time you will be sitting in?
yeah, actually, in evening, let me just